students, today we will learn about the valence shell electron pair repulsion theory, also known as VSEPR theory. 1940 ਦੇ ਵਿੱਚ ਨੀਵਲ ਸਿਡਵਿਕ ਅਤੇ ਹਰਬਰਟ ਪੋਵਲ ਨੇ ਇਸ ਥਿਉਰੀ ਨੂੰ ਡਿਵੈਲਪ ਕੀਤਾ ਜੋ ਕਿ ਲੂਇਸ ਸਟਰਕਚਰਸ ਤੇ ਆਧਾਰਿਤ ਮੋਲੀਕਿਊਲਰ ਸ਼ੇਪਸ ਨੂੰ ਪ੍ਰਿਡਿਕਟ ਕਰਨ ਵਿੱਚ ਬਹੁਤ ਮਦਦਗਾਰ ਸਾਬਿਤ ਹੋਈ। ਅੱਜ ਦੇ ਇਸ ਵਿਸ਼ੇ ਤੇ ਵਿਚਾਰ ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਆਓ ਅੱਜ ਦੇ ਪਾਠ ਦੇ ਸਿੱਖਿਆ ਉਦੇਸ਼ ਸਾਂਝੇ ਕਰ ਲਈਏ।
On completion of this topic, learners will be able to discuss postulates of VSEPR theory, discuss shape of molecules based on VSEPR theory, discuss shapes of molecules containing lone pairs and bond pairs, explain limitations of the VSEPR theory.
Dear children, let us now discuss in detail about VSEPR theory. 1940 ਵਿੱਚ ਸਿਡਵਿਕ ਅਤੇ ਪੋਵਲ ਨੇ ਐਟਮਸ ਦੀ ਵੈਲੈਂਸ ਸ਼ੈਲ ਵਿੱਚ ਇਲੈਕਟ੍ਰੌਨ ਪੇਅਰਸ ਦੀ ਰਿਪਲਸਿਵ ਇੰਟਰੈਕਸ਼ਨਸ ਦੇ ਆਧਾਰ ਤੇ ਇਸ ਸਿੰਪਲ ਥਿਉਰੀ ਨੂੰ ਤਜਵੀਜ਼ ਕੀਤਾ। ਫਿਰ ਇਸ ਨੂੰ ਨਾਇਹੋਮ ਅਤੇ ਜਿਲੇਸਪੀ ਨੇ 1957 ਵਿੱਚ ਡਿਵੈਲਪ ਅਤੇ ਰਿਫਾਈਨਡ ਕੀਤਾ। ਉਹਨਾਂ ਸੁਜੈਸਟ ਕੀਤਾ ਕਿ ਸ਼ੇਪਸ ਆਫ ਮੋਲੀਕਿਊਲਸ can be determined by the number of electron pairs bonding as well as non-bonding in the valence shell of the central atom. इस theory ਦਾ basic idea है कि molecule which bonded atoms adopt that particular arrangement in space around the central atom which provides them maximum stability. Let us now discuss the postulates of VSEPR theory. The main postulates of VSEPR theory are: the shape of a molecule depends upon the number of valence shell electron pairs, whether bonded or not, around the central atom. In certain cases, all the valence shell electrons may not take part in the bond formation. The electrons left in the valence shell without forming bonds exist as lone pairs. For example, in methane, that is CH4, carbon uses all the 4 valence electrons 1s2, 2s2, 2p2 in forming 4 bond pairs with 4 hydrogen atoms. On the other hand, in water, the central oxygen atom has 1s2, 2s2, 2p4, 6 valence electrons. The hydrogen atom shares 2 of these 6 valence electrons in bond formation, leaving 4 electrons as 2 lone pairs. Thus, in methane, there are 4 bond pairs around carbon, while oxygen in water has 2 bond pairs and 2 lone pairs around it, as shown on the screen. Electron pairs in the valence shell tend to repel one another because their electron clouds are negatively charged. The electron pairs around the central atom tend to occupy positions in space that is minimize repulsions between them. ਇਸ ਕਰਕੇ electron pairs ਜਿੱਥੇ ਤੱਕ ਸੰਭਵ ਹੋਵੇ ਦੂਰ ਹੋਣ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਦੇ ਹਨ ਤਾਂ ਜੋ ਮਿਨੀਮਮ એનર્ਜੀ ਜਾਂ ਮੈਕਸਿਮਮ ਸਟੇਬਿਲਿਟੀ ਦੀ ਸਟੇਟ ਐਕਵਾਇਰ ਕੀਤੀ ਜਾ ਸਕੇ। The electron pairs in multiple bonds are treated as a single unit like a single electron pair. ਦੂਜੇ ਸ਼ਬਦਾਂ ਵਿੱਚ ਡਬਲ ਬੌਂਡ ਜਾਂ ਟ੍ਰਿਪਲ ਬੌਂਡ ਦੇ 2 ਜਾਂ 3 ਇਲੈਕਟ੍ਰੌਨ ਪੇਅਰਸ ਨੂੰ ਕ੍ਰਮਵਾਰ ਇੱਕ ਸਿੰਗਲ ਸੁਪਰ ਪੇਅਰ ਇਕੁਇਵੈਲੈਂਟ ਤੋਂ ਸਿੰਗਲ ਇਲੈਕਟ੍ਰੌਨ ਪੇਅਰ ਤੱਕ ਕੰਸੀਡਰ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। ਇਲੈਕਟ੍ਰੌਨਸ ਦੇ 2 ਲੋਨ ਪੇਅਰ ਦਰਮਿਆਨ ਰਿਪਲਸ਼ਨ 2 ਬੌਂਡ ਪੇਅਰਸ ਦਰਮਿਆਨ ਰਿਪਲਸ਼ਨ ਤੋਂ ਜਾਂ ਇੱਕ ਲੋਨ ਪੇਅਰ ਅਤੇ ਇੱਕ ਬੌਂਡ ਪੇਅਰ ਦਰਮਿਆਨ ਰਿਪਲਸ਼ਨ ਤੋਂ ਵੱਖ ਹੁੰਦੀ ਹੈ। ਰਿਪਲਸਿਵ ਇੰਟਰੈਕਸ਼ਨਸ ਇਸ ਤਰ੍ਹਾਂ ਡਿਕਰੀਜ਼ ਹੁੰਦੀਆਂ ਹਨ। ਲੋਨ ਪੇਅਰ ਰਿਪਲਸ਼ਨ is greater than lone pair bond pair repulsion is greater than bond pair repulsion. The presence of lone pairs in addition to bond pairs will result in certain distortions in the regular geometry of molecules. Let us try to understand this. The orbital of bonded pair is under the influence of two nuclei and the most of the electron cloud is oriented between the nuclei of the two atoms. On the other hand, the lone pair of electrons is under the influence of only one nucleus, and therefore its electrons cloud is spread out and tends to occupy more space. For example, as you see on the screen, a molecule of ammonia is ਦੇ ਵਿੱਚ 3 bond pairs ਅਤੇ ਇੱਕ lone pair ਹੈ। lone pair central atom ਦੇ ਦੁਆਲੇ ਜ਼ਿਆਦਾ ਜਗ੍ਹਾ ਘੇਰਦਾ ਹੈ ਕਿਉਂਕਿ ਉਹ ਇੱਕੋ ਨਿਊਕਲੀਅਸ ਦੇ ਇਨਫਲੂਐਂਸ ਵਿੱਚ ਹੈ। ਇਸ ਕਰਕੇ ਉਹ neighboring orbitals ਦੇ electrons pairs ਨੂੰ ਜ਼ਿਆਦਾ repel ਕਰਦਾ ਹੈ। ਜਦੋਂ ਕਿ bond pairs ਦੋ ਨਿਊਕਲੀਆਈ ਦੇ ਇਨਫਲੂਐਂਸ ਵਿੱਚ ਹਨ, ਇਸ ਕਰਕੇ ਉਹ neighboring orbitals ਦੇ electrons pairs ਨੂੰ ਘੱਟ repel ਕਰਦੇ ਹਨ। ਇਸ ਕਰਕੇ lone pairs ਦਰਮਿਆਨ repulsions ਜ਼ਿਆਦਾ ਹੋਣਗੀਆਂ ਅਤੇ ਇਹ ਉਸ ਵੇਲੇ ਘੱਟ ਹੋਏਗੀ ਜੇ ਇਹਨਾਂ ਚੋਂ ਇੱਕ bond pair ਹੈ ਅਤੇ ਘੱਟ ਤੋਂ ਘੱਟ ਹੋਏਗੀ ਜੇ ਦੋਵੇਂ bond pairs ਹਨ। Students, let us now learn about shape of the molecules on the basis of VSEPR theory. This theory is very simple as it takes into account only the number of electron pairs present in the valence shell of the central atom. Thus, the particular geometry of a molecule depends upon the number of electron pairs around the central atom. उदाहरण ਦੇ ਤੌਰ ਤੇ ਜੇ ਇੱਥੇ central atom that is AB2 type ਦੇ ਦੁਆਲੇ 2 electron pairs ਹਨ ਤਾਂ ਇਹਨਾਂ ਨੂੰ ਇੱਕ ਦੂਜੇ ਤੋਂ ਦੂਰ ਰੱਖਣ ਦਾ ਇੱਕੋ ਇੱਕ ਸੰਭਵ ਤਰੀਕਾ ਇਹਨਾਂ ਨੂੰ ਘੱਟੋ ਘੱਟ repulsion ਤੇ 180 ਡਿਗਰੀ ਐਂਗਲ ਤੇ ਰੱਖਿਆ ਜਾਵੇ। ਅਜਿਹੇ ਕੇਸ ਵਿੱਚ ਮੋਲੀਕਿਊਲ ਸਕਰੀਨ ਤੇ ਵਿਖਾਏ ਅਨੁਸਾਰ ਲੀਨੀਅਰ ਜਿਓਮੈਟਰੀ ਨੂੰ ਅਡਾਪਟ ਕਰ ਲੈਣਗੇ। ਮੋਲੀਕਿਊਲਸ ਬਾਰੇ ਇਸ ਕਿਸਮ ਦੀਆਂ ਉਦਾਹਰਨਾਂ ਹਨ ਬੈਰੀਲੀਅਮ ਫਲੋਰਾਈਡ BeF2, beryllium chloride that is BeCl2, beryllium hydride that is BeH2 ਅਤੇ zinc chloride that is ZnCl2. Similarly, for 3 electron pairs around the central atom that is AB3 type, the molecule adopts trigonal planar geometry where the molecule exists in the single plane. The bond angles are of 120 degrees. Examples of this kind of molecule are boron trifluoride BF3 and aluminium chloride AlCl3. For 4 electron pairs around the central atom that is AB4 type, the molecule adopts tetrahedral geometry. The bond angles are 109.5 degrees. Examples is molecule of methane that is CH4. The molecules having 5 electron pairs around the central atom that is AB5 type have trigonal bipyramidal geometry. There are 2 types of bonds, axial and equatorial. These angles are of 120 degrees and 2 angles are of 90 degrees. Example of this type is phosphorus pentafluoride that is PF5. The molecules having 6 electron pairs around the central atom that is AB6 type have octahedral geometry. Example is sulfur hexafluoride that is SF6 having bond angle of 90 degrees. The molecules having 7 electron pairs around the central atom that is AB7 type have pentagonal bipyramidal geometry. There are 2 types of bond angles, 90 degrees and 72 degrees. Example is iodine heptafluoride that is IF7.
Let us illustrate the VSEPR theory by having a look at few examples. Let us first take up molecules with shapes of molecules containing bond pairs that is type ABN only. We will first learn about the shape of AB2 type molecules. For example, shape of BeCl2 molecule linear, bond pair 2, lone pair 0. आओ ਵੇਖੀਏ ਕਿ ਵੈਲੈਂਸ ਸ਼ੈਲ ਇਲੈਕਟ੍ਰੌਨ ਪੇਅਰ ਰਿਪਲਸ਼ਨ ਥਿਊਰੀ ਦੀ ਵਰਤੋਂ ਕਰਦਿਆਂ ਬੈਰੀਲੀਅਮ ਕਲੋਰਾਈਡ ਮੋਲੀਕਿਊਲ ਦੀ ਸ਼ੇਪ ਨੂੰ ਕਿਸ ਤਰ੍ਹਾਂ ਪ੍ਰਿਡਿਕਟ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। बेरिलियम क्लोराइड मॉलिक्यूल बेरिलियम एटम दे दुआले सिर्फ 4 वैलेंस इलेक्ट्रॉन्स रखता है। VSEPR थ्योरी दे मुताबिक they repel each other and turn to position themselves as far apart as possible. इस करके ਇਹ बेरिलियम एटम दियां opposite sides ਤੇ locate ਹੁੰਦੇ ਹਨ। Consequently, the molecule acquires a linear shape with an interbond angle of 180 degrees. Let us now take up the second structure, that is the shape of AB3 type molecules. For example, shape of BF3 molecule, trigonal planar. The central atom, boron, that is Z is equal to 5, 1s2, 2s2, 2p1, has 3 valence electrons. In the formation of boron trifluoride molecule, that is BF3, each electron in the valence shell of B atom forms a bond pair with fluorine atom. As a result, the central boron atom is surrounded by 3 bond pairs and molecule adopts trigonal planar geometry. In this geometry, all the F-B-F bond angles are of 120 degrees. This geometry is planar because the 3 fluorine atoms and the central boron atom lie in the same plane. Let us take up the next AB4 type molecules. For example, shape of CH4 molecule, tetrahedral. The central atom, carbon, that is Z is equal to 6, 1s2, 2s2, 2p2, has 4 valence electrons. All the 4 valence electrons are bonded to 4 hydrogen atoms, forming 4 bond pairs around the central carbon atom. These 4 electron pairs, trying to remain as far apart as possible, adopt tetrahedral structure. A tetrahedron is a 4-sided pyramid having equilateral triangular faces. In methane molecules, each of the hydrogen molecules is at one vertex of the tetrahedron. The interbond angle, that is HCH bond angle, is approximately 109.5 degrees. Shape tetrahedral. Bond pairs 4, lone pairs 0. Let us now take the fourth example of AB5 type molecules. For example, phosphorus pentachloride molecule, which is trigonal bipyramidal. Shape of the PCl5 molecule, trigonal bipyramidal. In PCl5, the central atom P, that is Z is equal to 15, 1s2, 2s2, 2p6, 3s2, 3p3, has 5 valence electrons. When 5 groups of electrons are in the valence shell of the atom, the molecule takes the shape of the triangular bipyramid, a figure made of 2 triangular pyramids joined by a shared triangular plane. For example, phosphorus pentachloride or PCl5 has 5 valence electron pairs. Because of their mutual repulsion, the molecule assumes a trigonal bipyramidal shape. Note that in this geometry, all the interbond angles are not the same. The bond angles in the central triangular plane are of 120 degrees, while those between a vertical bond in the diagram and bonds in the triangle are of 90 degrees. Shape trigonal bipyramidal. Bond pairs 5, lone pairs 0. In this geometry, all 5 PCl bonds are not equal. The 3 bonds lying in the trigonal plane are called equatorial bonds. Of the remaining 2, one lies above and the other below the equatorial plane, both making an angle of 90 degrees with the plane are called axial bonds. It has been observed that axial bonds are slightly longer than equatorial bonds in this geometry.
I hope you found all that very informative. Let me now ask you a question. Can you explain why axial bonds are longer than the equatorial bonds? I will tell you why it is so. The larger bond length of axial bonds than equatorial bonds can be explained in terms of the repulsive forces between electron pairs due to different bond angles.
आओ axial ਅਤੇ equatorial electron pair ਦਰਮਿਆਨ repulsive interactions ਨੂੰ ਕਾਊਂਟ ਕਰੀਏ। ਜਿਵੇਂ ਕਿ ਸਕਰੀਨ ਤੇ ਵਿਖਾਇਆ ਗਿਆ ਹੈ, axial bond ਦੇ electron pair ਨੂੰ bond 1 ਕਹਿ ਲਓ ਜੋ ਕਿ 90 degrees ਤੇ bonds 2, 3 ਅਤੇ 4 ਦੇ 3 electron pairs ਨਾਲ repel ਕੀਤਾ ਗਿਆ ਹੈ। ਦੂਜੇ ਪਾਸੇ equatorial bond ਦੇ electron pair ਨੂੰ 2 ਕਹਿ ਲਓ ਜੋ 90 degrees ਤੇ 2 electron pairs 1 ਅਤੇ 5 ਅਤੇ 120 degrees ਤੇ 2 ਜੋ ਕਿ 3 ਅਤੇ 4 ਹਨ ਨਾਲ repel ਕੀਤਾ ਗਿਆ ਹੈ। We know that the repulsion between electron pairs decreases with increasing angle between them. So, the repulsion between electron pairs at 120 degrees and 180 degrees may be neglected in comparison to those at 90 degrees. So, considering only the repulsions between electron pairs at 90 degrees, we observe that each axial bond is repelled by 3 electron pairs, while each equatorial bond is repelled by 2 bond pairs. This means that axial bond pair faces greater repulsion from other bonds and therefore the axial bond is slightly longer than equatorial bond. It may be noted that the structure of PCl5 molecule is unsymmetrical. As a result, it is less stable and is therefore highly reactive. Children, let us now study the shape of AB6 type molecules. For example, sulfur hexafluoride molecule. Shape of SF6 molecule, octahedral. In SF6, the central S atom, that is Z is equal to 16, 1s2, 2s2, 2p6, 3s2, 3p4 has 6 valence electrons. Each of these 6 valence electrons forms bond with fluorine atom and therefore the molecule has octahedral geometry. In this case, all the bond angles are same and are of 90 degrees each. Example, SF6. Shape, octahedral. Bond pairs, 6. Lone pairs, 0.
Let us now have a look at the shape of AB7 type molecule. For example, IF7 molecule, which is pentagonal bipyramidal. In IF7, the central atom I has 7 valence electrons. Each of these 7 valence electrons forms bond with fluorine atom and therefore the molecule has pentagonal bipyramidal geometry. In this case, all the bond angles are not equal. 5 electron pairs are in the same plane at an angle of 72 degrees while other 2 are perpendicular to the plane, both making an angle of 90 degrees with the plane. Thus, in this arrangement, 5 bond angles are of 72 degrees each and 2 are of 90 degrees each. Let us now learn about shapes of molecules containing lone pairs and bond pairs. Now, let us consider a few molecules containing bond pairs as well as lone pairs. Let us take up the first one, that is molecules containing 3 electron pairs, that is AB3 or AB2L. If the valence shell of an atom contains 3 electron pairs, then the molecule has trigonal planar geometry, that is BF3. However, if it contains a lone pair instead of a bond pair, the geometry gets distorted. For example, a molecule of the type AB2L has V-shaped geometry. L in the formula represents a lone pair.
Let us now learn about the shape of sulfur dioxide SO2 molecule. In SO2 molecule, there are 3 electron pairs, that is 2 bond pairs and 1 lone pair. The 3 electron pairs should acquire a trigonal planar arrangement with bond angle 120 degrees. Since one of the positions is occupied by a lone pair, the geometry may be described as angular or V-shaped or bent shape.
Let us now learn about molecules containing 4 electron pairs, that is AB4, AB3L, AB2L2. As already learned, the molecule AB4 has tetrahedral geometry. But if lone pairs are also present in addition to the bond pairs, the geometry gets distorted. This may be understood by taking 2 examples. Molecules containing 3 bond pairs and 1 lone pair, that is AB3L, such as ammonia, that is NH3. ਇੱਥੇ ਅਸੀਂ ਅਮੋਨੀਆ ਦਾ ਉਦਾਹਰਣ ਲੈਂਦੇ ਹਾਂ। ਅਮੋਨੀਆ ਵਿੱਚ ਇਲੈਕਟ੍ਰੋਨਸ ਦੇ 4 ਪੇਅਰ ਹੁੰਦੇ ਹਨ। ਇਹਨਾਂ ਵਿੱਚੋਂ 3 ਬੌਂਡ ਪੇਅਰਸ ਅਤੇ 1 ਲੋਨ ਪੇਅਰ ਹੁੰਦਾ ਹੈ। The shape should be tetrahedral, but actually it is pyramidal because repulsions between lone pair bond pair is more than bond pair repulsions. Thus, the angle between bond pair is reduced to 107 degrees from 109.5 degrees. For example, ammonia, that is NH3, shape trigonal pyramidal, bonding pairs 3, lone pairs 1. Molecules containing 2 bond pairs and 2 lone pairs, that is AB2L2, for example water H2O. The geometry of these molecules has already been discussed a little while ago. In water also 4 pair of electrons are involved. 2 of them are bond pairs and 2 of them are lone pairs. For example, water, that is H2O, shape bent, bond pairs 2, lone pairs 2. We take here the example of water. The shape of which is bent. The reason for this shape is lone pair repulsion is more than bond pair repulsion. Thus, the angle is reduced to 104.5 degrees from 109.5 degrees. Examples of molecules with 5 electron pairs but with lone pairs: AB5, AB4L, AB3L2, AB2L3 are SF4 and ClF3. These are both variations of the trigonal bipyramid. The lone pairs always occupy equatorial positions. Equatorial pairs have fewer 90 degrees repulsions and thus are at lower potential energy. This is consistent with the longer axial bond lengths seen for PCl5. The greater repulsion of these lone pairs distort or bend both the axial and equatorial Cl atoms slightly away to the opposite side of the molecule. Let us now take the example of AB2L3, that is XeF2, as shown in the figure on the screen. Let me tell you that the shape of the molecule is linear. ਇਸ molecule ਵਿੱਚ Xe central atom ਦੇ ਆਲੇ ਦੁਆਲੇ 3 lone pair ਅਤੇ 2 bond pairs of electrons ਹਨ. Let us now learn about molecules containing 6 electron pairs: AB6, AB5L, AB4L2. When the central atom is surrounded by 6 electron pairs, the geometry is octahedral. However, if one or more of electron pairs is lone pair, the geometry gets distorted. This may be understood by the following examples. Molecules containing 5 bond pairs and 1 lone pair, that is bromine pentafluoride, that is BRF5. Molecules containing 4 bond pairs and 2 lone pairs, that is xenon tetrafluoride, XeF4.
Let us take up the first one, AB5L, that is 5 bond pairs and 1 lone pair molecules. Bromine pentafluoride the उदाहरण लो. Central bromine atom, that is Z is equal to 35, 4s2, 4p5, ਦੇ 7 valence electrons ਹਨ. Bromine pentafluoride, that is BRF5, the formation which 5 bond pairs and 1 lone pair ਹੁੰਦਾ ਹੈ. 6 electron pairs octahedral geometry ਰੱਖਦੇ ਹਨ, ਜਿਨ੍ਹਾਂ ਵਿੱਚ ਇੱਕ ਪੋਜੀਸ਼ਨ ਇੱਕ ਲੋਨ ਪੇਅਰ ਨੇ ਆਕਿਊਪਾਈ ਕੀਤੀ ਹੁੰਦੀ ਹੈ, ਕਿਉਂਕਿ octahedral geometry ਵਿੱਚ ਸਾਰੀਆਂ ਹੀ 6 ਪੋਜੀਸ਼ਨਸ ਇਕੁਈਵੈਲੈਂਟ ਹਨ. ਇਸ ਕਰਕੇ ਲੋਨ ਪੇਅਰ ਨੂੰ ਕਿਸੇ ਵੀ ਪੋਜੀਸ਼ਨ ਤੇ ਪਲੇਸ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ, ਜਿਵੇਂ ਕਿ ਸਕਰੀਨ ਤੇ ਵਿਖਾਇਆ ਗਿਆ ਹੈ. The geometry of BRF5 is termed as square pyramidal. And now the second one, AB4L2, that is 4 bond pairs and 2 lone pairs molecules. Let us take the example of xeF4. In this case, the central xenon atom has 8 electrons. In the formation of xeF4, there are 4 bond pairs and 2 lone pairs. The 6 electron pairs has octahedral geometry as shown on screen, in which 2 axial positions are occupied by lone pairs by keeping the 2 lone pairs as far apart as possible, that is at 180 degrees. The structure is termed as square planar.
Let us now have a look at the limitations of the VSEPR theory. The VSEPR theory is simple yet powerful. Nevertheless, like any simplified model, it has its limitations. First, although it predicts that the bond angle in water is less than the tetrahedral angle, it does not make any attempt to predict the magnitude of the decrease. Second, the theory makes no predictions about the lengths of the bonds, which is another aspect of the shape of a molecule. Third, it ascribes the entire criterion of shape to electrostatic repulsions between bonding pairs, whereas in fact there are numerous contributions to the total energy of a molecule, and electrostatic effects are not necessarily the dominant ones. Fourth, the theory relies on some vague concepts, such as the difference in repelling effects of lone pairs and bond pairs. There also are some species for which VSEPR theory fails. It fails to explain the formation of chemical bond. It also gives no idea about the shapes of polyatomic molecules. It also could not give any reason for the difference in bond dissociation enthalpies in different molecules having same type and same number of bonds. Nevertheless, despite these limitations and uncertainties, VSEPR theory is a useful rule of thumb and can be used with reasonable confidence for numerous species. ਬੱਚਿਓ, ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗਿਆ ਹੋਵੇਗਾ। ਧਿਆਨ ਦੇਣ ਲਈ ਧੰਨਵਾਦ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ। ਤਦ ਤੱਕ ਲਈ ਇਜਾਜ਼ਤ ਦਿਓ।